the three peers I should evaluate. So, is there any problem that I would face since I have already evaluated?
Since many of you are facing this problem, I don't think there will be any problem. But yeah, I'll check today, and then tomorrow you'll be getting some information regarding that for sure.
Okay, sir.
Yeah. So mostly you were raising the concern regarding this extra activity and the peer, right?
Yes, sir,
On the
because
Discord also.
we are now we are not able to review or not able to get our not able to see our
This
scores.
was the first time you are doing this, or
Yes, sir, first time.
Yes, sir. First time peer evaluation, and then no grade option over there.
okay.
Like
Okay,
1 to 100, what marks we should give.
when is your submission for the graded thing? Tomorrow, day
That
after
is
tomorrow.
12th, I think. 12th. We have to do before 12th January.
So both the week, first and second, or
For week 0, there's 2 activity, and both the deadline for both extra activities is 12th January.
week 0 is not compulsory, right?
No, the extra activity is, from week 0.
When you have to submit week for extra activity thing.
Sir, I'm unable to understand.
Yeah, please mute yourself. One second.
I think this is from the team side of the MA 1004.
Yeah. One second. Tell them to.
Yeah, host is speaking.
Yeah. Yeah. So yeah, maybe mistakenly that. Okay. So what I was telling, I forgot. Yeah. So when is that date for the submission for that week 0 extra activity thing?
12th January.
The submission date, actually the deadline is over, but we can review till 12th January.
Okay.
Yeah.
And for the graded thing?
Graded thing is also over. It's, I think, 5th January was the deadline.
For week 1, 9th, I guess, right?
No, week 0, week 1 both, because week 0 doesn't have any graded assignment. So the week 1, the deadline was 5th January, and week 2 it is 12th January, I think.
Okay, nice. So how is the course going on? It's pretty.
Yes, it's good. It's 80. I got 80, so it's, I think, good for me.
Okay. So is the course for everyone? How was the first week and then the next one, this week?
This week, actually, I only did activity questions till now. I haven't approached.
So we are struggling to solve the questions.
Yeah, so one thing I would like to point out is we were put to a rough start. When we started, we were immediately given week 1 along with week 0 part 1, part 2, part 3. So it was
week 0 was totally whatever you've studied in stats 1, right? So,
yeah, but then we all thought that, but then we got a mail that some concepts were
that was just for the sake of practice, but yeah, for week. But have you most of you would have went through the content, right, for the week, second week?
Yes,
Yes, sir.
I've completed the activity questions, but didn't start the practice assignments.
Yes, I've done the same. Or started the practice assignments yet.
Fine. So yeah, I will discuss regarding the activity and practice only today. And then if you're somebody has saw the graded and is not able to, so can I ask some question, I can give you some hint sort of thing. So yeah, Sasi has raised the hand. Yeah, Sasi, tell me, you can unmute yourself and then ask. What's your doubt?
Sir, I have a conceptual doubt, sir. Like, how can you explain the concept of identically distributed binomial distribution? Like,
Okay.
a minimum and maximum of IIDs of binomial distribution. That concept I am not able to understand.
Yes,
Okay.
sir, I have also the same doubt that minimum of two random variable and that formula minimum max of IID sequences.
Okay.
That's
Anybody?
that.
Okay. Yeah, we'll discuss that.
And sir,
So, yeah.
can you explain the sum of two independent Poisson's derivation?
Okay, fine. I'll see that also.
Sir, I have one doubt in activity question.
Okay, yeah, we'll start with activity. Yeah, we'll see that ID. Okay, I'll write somewhere. Whatever I have discussed.
So when will the graded one solution will be uploaded?
It's not like, when was your final like submission date? 5th?
5th
Yes, sir.
January.
It's 5th January.
Okay, so it will get uploaded maybe tomorrow, or okay, after this meeting, I will tell them to upload. So tomorrow morning it will get uploaded for sure.
Okay, sir. Sir, also I have doubt in activity question of week 1 where Poisson is used. Poisson random variable is used. So if you can explain the Poisson random variables, so it will be fine to me.
Okay, Poisson you are asking, right?
Yes, sir.
Okay. Yes, I'll write first.
I have doubt on activity 2.4, question number 4.
Now you can see my display, right?
Yes,
So
sir.
I have doubt from the lectures.
Okay, so IID I have to discuss. Then what was that?
Sir, maximum minimum of a binomial distribution.
Maximum minimum.
Sum of two independent Poissons and random variables also.
Okay.
And sir, drawing contours.
Okay, drawing contour.
So Poisson distribution.
Okay. Poisson distribution.
Sir, geometric distribution also.
These are all concepts of, I guess, stats 1, right?
Right, sir.
So
Sir,
memoryless
and
property.
would we have the office hours? I mean, we got the mail that it has been cancelled, but I'm not very sure if.
For this week, I'm also not sure. But if you have got the mail that it has been cancelled, then it must be cancelled. But I need to
sir,
check
then
that.
where do we clarify our conceptual questions then? Because in this week, if we are taking the activity questions and the week 2 related specific content, then where would we clarify the questions like Poisson distribution or geometric distribution, or perhaps there are some more conceptuals that not even I have. Where do we clarify that?
Okay. So what we can do, we can have one more session on Sunday. I'll be taking that. So I can tell them to have one, like they can put on a Monday or Sunday or Monday. That would be fine to everyone, right? So for 2-hour session, I can discuss the week 0.
Sir, office hour is scheduled on Saturday.
Saturday?
Yes, sir. From 8 to 9 p.m.
But some of you are telling it has been cancelled.
Yes, sir, it is scheduled 8 p.m. office hour for statistics.
Did we get an email? Because I was aware that it has been cancelled. Is it something new?
It is cancelled only for that first week. For this week, it is there. If you look at the calendar, it shows. But the problem is both max and statistics both are on the same day, on the same timing also.
Sir, can you explain the memoryless property of the geometric distribution?
Okay.
Sir, on Sunday there is no session, so can you take one session on Sunday?
Yeah, that is what I'm telling. So okay, Sunday you don't have in the evening, right?
Yes, sir.
So okay, I'll take the session for 2 hours, and where I can discuss the week 0 and week one things, right? Is that fine for everyone? So if
Yes, sir.
Yes, sir.
okay, I'll tell the team to make an announcement regarding that on Sunday for 2 hours. We can discuss some of the topics like Poisson or geometric. I'll discuss now also in brief, but yeah.
So one thing like why do we not have the tutorial videos like stats one? Like it was very helpful for us.
Yeah, so we are preparing for stats too also. Maybe from next week you'll be getting. So yeah, so we are working on that. So we are mostly we are like solving some of the questions in the tutorials. So maybe from next week you'll be getting for sure.
Okay, sir. Thank you.
Yeah, yes, sir. This is required. What would
So
be
I have
what,
small doubt in lecture 2.2.
sir? What would be this timing for the Sunday session?
That you'll be getting through the announcement. Like I'll ask you tomorrow if anybody would be free, they can like announce regarding that. And because I am free on Sunday, so I can take.
Please, sir. We are facing so much difficulty in this. That's true. For the beginning also. Around
yeah.
So the content is more and time is less. This is the reason. So without practice, we cannot proceed.
Yeah, I can understand. Like in stats too, there are some concepts that is pretty like not difficult, but if you watch the video twice,
it is
maybe
not difficult, sir. The concept and the formulas should be implemented properly in the actual cases. That is the difficult. So how to approach to fit the actual cases with the formula? If you do in the live session, then I think everybody will be able to solve the problems. I think so. If everybody is comfortable, then this will be
better. Yeah.
Some of us are direct entry, so we don't have that much basics. We haven't studied a stat one.
Okay, yeah, okay, yeah. So I'll start with IID and question number you can tell me regarding the activity also. Okay, after this I'll ask the activities. So the first one is
excuse me, sir. So in
Yeah.
lecture 2.2, I have just a very small doubt in a very small part.
Okay, I'll open that lecture. Where is that? 2.2, right?
Yes, sir.
This one.
Yeah. So it is about 21. It's on 21. Yes.
Okay.
So this third part.
So yeah, what is that? Okay, you're asking why 14 by 16. I guess you're asking this.
Yeah,
Huh?
yes, sir. That's the problem here.
14 and 16. 14 we are taking because we are not including 3 and 4 both. Okay, if you not include 3 and 4, so then the probability of happening 0, 1, 2 is what? You'll just reduce 2 upon 16, right? So 14 upon 16 will be the probability.
So
Okay.
I didn't understand 14 upon 16.
Okay, see, here's what A we have defined as taking, what is that written? At 3 at least once. Okay, so it's taking 3 at least once and 4 also at least once. B has been defined as that one. So A complement is the opposite of that, right?
Yes, sir.
So for probability for happening 3 is also 1 upon 16.
Yes, sir.
Occurring. So not occurring would be 15 by 16.
Yes, sir.
Similarly for that 4 also.
Yes, sir.
And if 3 and 4 both are not occurring, so what would be the probability? Like we'll just reduce 1 minus this 2 upon 16.
Yes, sir. 1 minus 2 by 16.
Yeah, that is what 14 upon 16. That minus 16.
1 minus 2 by 16 means 1 minus 3 not occurring or 4 not occurring.
Yeah, both are not occurring.
Okay, both are not occurring. Okay.
It's not or, it's actually say and. It's
And
yeah.
Yeah, it's an and. So that's why 1 minus, what was that? 1 minus 16 and then 1 minus 16. So it would be 14 by 16, right?
Yes, sir. So in the lecture, if you can just move a bit forward.
Okay. Yeah.
Yeah. So why it is 2 times probability of A complement union B complement is 2 times 15 by 16 to the power n minus 14 by 16 to the power n.
I need to see the whole video then. 1 second.
Yeah, actually, it's A probability of A complement.
Probability
What?
of A complement
A
to B
complement.
B formula.
I guess.
Okay. Union formula, it's there.
Yeah.
Okay, sir. Okay, sir. Thank you, sir.
It's because
Yeah.
P of A
I have the
plus P
same
of
doubt.
B minus that intersection. So
I have a
altogether.
doubt here. So can
Okay.
you explain the memoryless property? Memoryless property.
Where is that memoryless property, in which
Sir,
video? Can you tell
sir,
me?
in this video, sir, in this video, same one.
Same video. Okay.
Yes, sir. Sir, can you please forward a bit? The last portion of the video is.
Please mute yourself like everybody else can hear, right?
No, sir. Sir, last part around 2033.
Okay.
Yes,
20.
sir. Yes, sir. Yes, sir. Yes, sir.
Here.
Yes, sir. Same.
Okay. So memoryless property. Okay. So have you got the first point? Like probability of x greater than n is this one.
Sir, I have
Geometric.
got. Sir, I knew all the points. I understand every probability. Just I want to know why is it called memoryless property? I'm not getting any kind of intuition like that. Why it is called so?
Memoryless, why it's calling, because there is no use of this value m. Memoryless means what? It's not remembering anything. See, what was that value?
I think if you take the activity 2.3 as example, it would be easy to understand this concept.
Yes, it's like if
I have done an example. I knew what's the concept, but I am actually want to know why the memoryless concept.
Because
So it is like,
see, in the end, you're not getting anything in the form of m. Have you, like, if you put m will get cancelled. That's why it's called memoryless. There's nothing like.
No, sir. Like it's like the results of the experiment that has already been done has no impact on the result that is going to be performed. So the memory that is getting erased, like the
yes,
results.
exactly.
Yeah.
It's like, yes, exactly. It's like you tried 100 trials, and if it is given that in 90, if it you know that in 90 trials you didn't get success, then it means and what is the probability that success will be in 100 trials is same as what is the probability that the success will be in 10th trial. If you know that in 90 trials you get failure, then you can remove that 90 trials and then try to find out the probability of success.
Yeah, it's
in 10
similar to
trials.
that. Like, you're correct. Like if you have done something like 1,000 times and then again you are starting from that 1,000 point, so you'll be getting the same probability if you are starting from initial point or from that. Like if you have started something here, okay, and you have done, like, that's a property of geometric also, you can say, and then you have done 1,000 times the same thing, and now again you are starting from here. Okay, so if you are starting, if you have, like, if, the probability, like whatever you have started and you have calculated from here also x greater than 2, and now also if you are doing and you are calculating the probability of x greater than 2 from here also, after doing so many like trials also, you'll get the same probability. That is what generally you can like understand as a memoryless thing. Like you were also trying to like say the same thing, right?
Yes, because if it is given that in 1,000 trials you didn't get success, then it will be the same.
So okay, so what was that next? So maxima minima thing. So where is that maxima minima, in which video? Can you tell me? Maxima. Okay, so
that's the 8th video, I think.
Last videos.
Last video.
So you are having the like problem in, okay, so CDF and PDF was the thing, right? You are having the problem calculating the CDF thing.
Yes.
Okay.
So my understanding of this, the way that it is written, maybe once you open one of the lectures, we are supposed to calculate the probability when.
Okay, here maximum minimum you are asking, right? Same
Yes,
thing.
yes, that maximum minimum for IID sequences.
Okay. So see, so you won't face any problem in calculating maxima, right? You'll be facing the problem a little bit in the calculating the minimum, right? If you are if you're having some x1, I'll write it.
So may I request you to just do an alt tab? Maybe if you can go back to the same screen, the video.
Yeah. So okay. So
Sir,
here I can't write.
The
I can
second,
just
no,
tell
no.
you.
I'm just telling you my doubt. What is the doubt?
Okay.
Sir, in the second line, it says
this
the
one.
first line is max xy lesser than z.
Yeah, maximum of xy
lesser than z. The second line, we are just calculating the probability of x lesser than z. But we are supposed to take the probability first of which is lesser and then whether it is less than z. That is my understanding. Maybe you can explain in your words and the flow.
This is what is the generally the CDF is if we are have to calculate the CDF is what? You just have to add all the value till z, like you have to add all the PDF till z, right?
Yes.
That is what you generally do for the CDF.
Right.
And here is what the PDF and z is what maximum of xy, like capital Z, or you can say any function like in probability. How do we generally calculate? See, if you are having something like normally x. So this CDF is generally we have to calculate the probability such that x is less than x, and this is what the if you are doing the summation of all the PDF. Okay, till x. That is what you generally do. So here also it's the same thing. Apart like the function x, here it is maximum of xy. Okay, maximum of like x and y are two random variables, and then whatever the value we are getting from x and y, maximum will be taking. Okay, and that should be less than g, that z. Okay, and then the second thing is if we are having like if that maximum of xy is less than equal to z, that is what the CDF is. Then the second term would be both of them should be less than equal to z. Then only you'll be getting z, less than z, right? Have you got? Okay, I'll try to explain in another way.
Sir, regarding this question, there's an activity exercise 2.11 question number 4.
Yeah, I'll go to that. First, I'll explain. So see. So you don't have any problem in writing the CDF. Here is generally the CDF you have to calculate, okay? And the one thing is all are independent. That is how, please mute yourself. Everything is independent, okay? Like all the random variables are independent of each other, like x and y here is independent. So if we have to, like CDF we have to calculate, we just have to write whatever the function you'll be having. Like here the function is maximum of xy. So it should be less than equal to z, because it's the definition of CDF, right? The first line. And the second line, just the elaboration of the first. If we are having the maximum of xy is less than equal to z, then both the random variables should be less than equal to z, okay? And then, because it's a and it's a independent, so we can just write in the form of product form. If that was not in the independent, then we would have written in the form of conditional multiplied with marginal, okay? But here it's an independent, so we can write directly both the marginal thing. So P that the margin of x and margin of y. And this is what? This is the CDF of x and this is the CDF of y. But in the minimum case, we can't write it directly.
So, but how are we getting max with this second line? How do we get max between x and y?
Actually, we are not getting max. We are getting the probability that max will be less than z. So we are getting the probability that max will be less than z.
Exactly. And that is what I am having difficulty to understand. If we are not getting max, then what is the role of this max in this whole function?
No,
we are just getting x is lesser than z and y is also lesser than z. But the function is max.
No, max is going to be lesser than z. It is saying that what is the probability that max is going to be less than z. The max, whatever max will come, like max will come 1, then 1 will be less than z, says z is equal to 2. Then it is saying that what is the probability that max which is coming 1 will going to be less than 2. That's it's kind of like that.
So maybe the way we can interpret it, if the max is less than z, obviously the other smaller one is also going to be less than z. So both
exactly.
Yeah.
That's how it has been expanded.
Yes.
Yeah,
exactly.
Correct. So have you got like who was asking Apul, I guess, no?
I'm trying to understand what is being said.
Okay, well, one example is there. Maybe with that example you can understand. And for the minimum, so for the, see, that is what. So we are having, see, maybe here you'll understand. Okay, for the maximum we can write directly because we have to get less than equal to, all the things should be less than equal to z. And for that, each of the trials should be less than equal to z. And if we are calculating for the one, we can just multiply with the n thing because all the things are identical. Everything is identical. So we just have to calculate for one random variable and then we can do it for the n random variable also. Okay. But for the minimum, we can't. Yeah. So, but for the minimum, we can't directly, we can write in the form of this also, but that will not help us to calculate CDF. Okay, that's why we'll write in the form of this and then we can do the 1 minus thing. Okay, 1 minus that P of minimum and then we can subtract the Z also whenever the value of all the random variable was equal to Z. Okay, that we can do in the minimum. So, okay, we'll see the example. Maybe that will help you to understand that. So there was the example. Yeah. So was there any doubt in this one? Like, see, this is a like joint PDF has been given the table form, and then you have to the first like function is minimum of xy, and the second. See,
Yes,
this
sir, I
can
have
be
doubted this
approached
question.
in the form like if you think in the normal, if you just forget about the lecture, okay, for some time, and then just think in a basic like approach. How will you approach if you have been given the simple thing? Then maybe you'll be able to answer. But if you're just thinking about okay, how it was taught, like that also, if you watch twice or thrice, that will like you can grasp. But for this question, you don't have to know anything like regarding the lectures also. You can just solve with the help of your like basic understanding about the probability. So here, all the joint, all the like joint PMF has been given, and the first question, the first function is the minimum of xy, and the second one is the maximum of xy. See, and the third question is the maximum. You have to calculate the maximum, okay, and this one maximum.
Can I interrupt once? Actually, there is a problem with this third question only. What is the capital F is given? What is that? I don't understand. The first
two is
CDF. Okay, that is called CDF. Okay.
CDF is what you have to do. This CDF you'd be knowing, right?
Yeah.
Just you have to calculate the probability till x.
Okay. Okay.
Okay.
Okay.
So here, so PZ2 of 1 you have to calculate. 1 here simply means don't think about the lecture, what has been taught. The thing here it is 1, and 1 means what? You have to calculate the probability such that Z2 should be less than equal to 1, right? So less than equal to Z means what? Means Z2 can be equal to 1 and 0, right? Because you can see the value of Z from here also. What are the value that Z2 is taking? Z2 is generally the maximum of xy. Okay, and x is what 0, 1, 2, 3, and y is 0, 1, 2. So maximum of xy, if you see from z, if you just think, this is the like longer way to calculate, but yeah, you will be able to understand that. If you first calculate all the values, the range where z2 is there. So maximum of x2 is what? You will take from starting 0, 0. So you'll be having what you have to know regarding that. You have to see So first you should be knowing what are the Z value it can take. So maximum, so if we are having 0, 1 and 2, 3, and we have 0, 1 and 2. This is for X and this is Y. So maximum of XY, what can be the value of maximum of XY? If you are taking randomly, just take it from the starting to end point. So Z2, what can be the value of Z2? Can anyone tell?
0, 1, 2, 3.
Okay. But here we have to get Z2 should be less than equal to 1, right? So what can be the value, 0 or 1?
Yes.
Yes.
So probability first, Z2 like the maximum of XY, maximum of XY should be equal to 0, or probability maximum of XY should be equal to 1. That is what you have to calculate. So how can you get maximum of XY equal to 0? When X and Y both are 0, then you'll get one thing.
No.
Yes.
When
both are 0, then we will get 0.
If you'll get anything like X equals 1 or anything apart from 0, you'll not get that, because if 1, you'll get 1 then. If X is anything else than 0 and Y also, like both should be 1, 0, 0, right? This is for the first condition. And for the second, maximum XY should be equal to 0. When you will get this?
0,
1, 1, 1, 1, 0.
0, 1, 1, 1, 1,
1, 0.
1, 0.
1, 0,
1, 1.
0, 1, and 1, 1, right? Okay. So how many, like 1, 2, 3, 4. At 4 places you'd be getting, so 4 upon 12, because all the things are uniformly distributed. Okay. So 1 upon 3 would be the answer. First thing, this is the first way to approach this. So what we have done from the starting, we don't know anything about the lecture. We just know, okay, Z2 is a function defined as maximum of X and Y. What are the values that we have the table? X can take 0, 1, 2, 3, 0 to 3, and 0, 1 to Y can take. What are the values?
This makes clear to me, because I was missing that part of max not coming when we were taking that lesser thing, but this is now clear. Thank you.
Yeah. Okay. So similarly,
so same activity, question number 5.
Okay. So this is clear, right?
Yes.
So can you explain the question number 3 in this activity?
Okay.
That CDF.
Yeah, question number 3 only I was explaining.
Okay.
Yeah.
Is it? Okay.
And then we'll move to the 5th one.
No, I don't think it is 3, because there is no that answer is given, no? 1 by 3 or something.
1 by 3 is the answer, right?
That is okay. Okay. Then can you do it for the fourth question?
Okay. So for the fourth one, is also you can think in the similar way. What is that? In the similar way, you can think, see, here it was maximum. So you can think of Z as minimum of XY.
Okay, fine. I can do it.
Yeah. So in the similar way, you can think of that and then you can calculate. Now we will move to the fifth one. So fifth one is all the 10 random variables are identical and independent. Okay, with the binomial 6, the number of that trial, and then not trial, and 1/2 is the probability. Okay, so we have just defined. Okay, so we have just defined Z1 as the maximum of all the random variables and Z2 as the minimum of all the random variables. Okay, so here is what. Here we have probability we have to calculate for Z1 less than equal to 2, right? So, and Z1, we already know Z1 is what? Maximum, right? Maximum, it was maximum, yeah. So it is maximum of all the things. Maximum of x1, x2 till x10, right? So what we can do, so all the 10 random variables are identical. So we just have to do it for one, and then we can just multiply with, like, multiply that 10 times. Okay. So now probability of this thing, maximum of all this thing, x1 till x10, is less than equal to 2. That means what? It should be 0, 1, or 2, right? Right? This is similar to that. This is CDF only, because this is asking for less than equal to z, small z. That is what discussed in the lecture. So small z is 2 here. So just think from the basic probability, how will you approach if the probability has been asked maximum of all the random variables? Just think of the one only, maximum of all the random less than equal to 2. Then the x1 should be 0. X1 can be 0 or 1 or 2. Okay. So now you are having 3. So how we generally do in the binomial? Okay. So out of 6, we have got 0, head or tail, whatever you can assume, like 1/2 is the probability. So out of, for 3, we can do it for this one. PDF would be 6C0. So 1/2/6, right? Similarly for this 6C1, 1/2/6, and similarly for this 6C2, 1/2/6, right? And you can do the summation. This for 1. And you can just multiply it 10 times. You'll get the answer. Have you got, like, see, I'll try to explain it again. Z1 was the function with was coming at maximum of all the random variables, like 10 random variables. And the question was, you have to calculate the probability. This can be defined as a PDF, CDF. CDF is what? You just have to do the summation of all the PDF till 2, like till whatever the value has been given here. Okay. So now the maximum should be 0, 1, 2. Okay. So for the 0, we have binomial of 6, 1/2. So you can just write the PDF how generally we write NC, the number and the outcome 1/2, this n minus r times 1/2 r. Okay. So for 0, we have defined 60, 0, 1/2 divided by 6. Like if you will add this, n minus r plus r is n. So this one. So you'll be getting 60 is what? 1 plus 61 is what? 6/5. And then 62, 6/2. So you'll be getting something like 15 plus 6, so 21 in the numerator, and then 2 to the power 6 in the denominator, so 21, and then you'll be multiplying 10 times because we are doing for the 10 random variable. This was explained in the lecture. If you got something for the one thing, you can just multiply it n times because you have the n identical that random variable. Maybe have you got like, am I able to like explain you in a proper way?
Yeah, that's fine. Okay.
Yeah. So what is the next now? So maximum, minimum, we have covered, and then the drawing contour. Okay. So what was the problem in drawing the contour? You just have to see wherever, see if you are having some function. Some of the basic thing I'll tell you for the week 2. The contour thing, see, if you're having some x and y defined, like x has been defined and y you have to x minus 2 or something has been defined, and for the random variable x, the probability PDF has been given for all the values. So you can calculate y also, the range, and then for all the range, if you are getting some x, so you can just see wherever x is there, you can just add the PDF. Okay, PDF, and then you'll get the probability for this y is equal to x minus 2. So if what generally we are doing, we are just adding all the values, that all the values wherever the x was present in the x, right? So that is what we are doing, like doing the summation. And if you'll go in the, if you are having some functions like random variable as x plus y or something like that. So here what you will do, you will calculate the range for each of the x and y if you have been given x and y, and if you have been given PDF, not PDF, the joint PDF if you have been given for xy. So here what you will do, you will just add the, so earlier what you were doing, you were having the simple function, so you were just calculating the range and you were watching wherever that range was there, you just have to add the PDF and you will get the probability density function for this one. Okay, what you are doing here, you are just adding the PDF, so don't get confused with that. Here we are just adding the PDF wherever x was there, and here we are doing the joint PDF, we are doing the summation wherever the range we were getting. Okay, so first thing, but many a times what you'll do, you'll add for the x or y, so that will get like you are like having some problem that understanding the concept. So one thing it should be there in the mind, wherever you have to do, if the function is in the form of more than 2 or 3, whatever the function is there, and you have been given the joint PDF, then you can just do wherever this, if you are getting some lambda, so wherever the lambda is there, you can just add for those range, you can just add the joint PDF and you'll get the that probability for that lambda. Okay, I guess are you able to hear me or what?
Yes, sir. Yeah. We are
Yes.
able to hear you.
Yes, sir, we are able to hear you.
Yes, sir. One thing, sir, because the topic is so complex, so we are not responding to this is one thing, sir. If it is possible,
Can we do with
right,
a simple,
in the maths,
simple example
sir,
that would
in maths
definitely
too.
help actually?
One thing, sir, I
Yeah.
like to suggest in the maths too. In every, because in vector space, because that was the new topic. Like this is also like that. So if keynotes is it possible to share in the session, keynotes were there, key points for the lectures. The lectures are just for the conceptual clarity. After that, if key points are there, then we will be able to grasp on the basis of that key points, problems were being solved in the match 2. If it is possible, sir, it will be very convenient to follow the lectures and respond it properly. We are doing, but we are facing some problems. I am facing, other people are facing, or not. 146 people are there here, but I think response is not like that. So if it is possible, then we can do it like that. We are doing our hard, but not responding like that. Just I would like to share. That's our
What is that?
Sir, I have doubt on activity 2.4, question number 4.
So 2.4.
Yes.
Yeah. Which question?
Question number 4.
Okay. So here is what X is the geometry. Okay, please mute, yaar. Please. So So here X is a random variable in the form of geometric with P is the probability, right? So, and then the function has been defined as x by 2 and x plus 1 by 2, where x is the even number and x here. Okay. So you'll be getting the range as what? If you'll put some even number, 2, if you're putting, you'll get 1. Then 2, 3, 4, 5, 6, right?
Yeah.
And then from here also, if you're putting some odd number, you'll get the same thing. 1, 2,
Same
3,
number,
4.
yes.
So what you can do, you can what is that? X, just equate this function if you are having, okay. So for that k, you have to calculate the probability. So if you are equating x by 2 equals k, what you will get?
It can be, it depends. When it will be even, then k will be different.
X could be 2k. X could be 2k, right?
2k and 2k minus 1. Or 2k minus.
What was that? One was x by 2 and then the other was
x plus 1 by 2.
X plus 1 by 2.
So you just have to define for both the things. Like for x is equal to 2k, and then for that, if you are defining x is equal to k, this is for even and this is for odd, right? So x here will be 2k minus 1, right?
Yes.
Yeah.
So now you have to calculate the probability.
Yes.
So you are having the geometric thing. So in the geometric, how generally you calculate the probability for probability x greater than some x greater than some n, okay? You generally do that thing. Like in the geometric, the geometric distribution is like, what's the, like how many, like if you start tossing the coin, okay, and then you have been asked after like, what's the probability that you'll get the head after fifth turn, after fifth trial, okay, or after nth trial. This is similar. This is the geometric distribution. Somebody asked in the starting, like if you have started some doing trial for, like if you have started throwing the dice for n number of times, and then you have been told to what's the probability that you'll get 6 after fourth trial, okay, so after nth trial. So if you have been told to calculate after nth trial, that means what? Till n minus 1, you haven't got that 6, right? So what's the probability of that? The probability of not getting that is 1 minus p till
n minus 1.
minus 1th term, okay, because we are calculating for greater than n. And then in the nth term, if you have got, that is the probability, okay. So you can do the summation also, like this for the n, and then for the n plus 1 and then n plus 2 and all. So you can do the summation to calculate the probability. Like for example, after fourth term means what? He can get in the fifth, he can get in the sixth, or he can get in the seventh till infinity, right? And you can add that, add those probability and you'll get. So here, what was asked? So here you have to do it for x is equal to 2k and for the 2k minus 1, right? So generally there is one formula maybe have been discussed in the lecture also. If you're having some x is equal to n, so what is the generally, anybody generally remembers that formula that has been taught in the lecture?
For geometric variable, random variable.
Yeah.
1 minus p to power n minus 1 into p.
Oh, that is the simple geometric thing. Yeah, that. Okay.
Into p.
That
So
you can
1 minus p to the power n.
No, it's for j. It's for g equal to n. Probability of g equals to 1.
Okay,
n.
that is for if you are doing anything n number of times, right? So
yes.
j trial n number of times, then you'll be having 1 minus p to the power jn, right?
Okay.
Yes.
Yeah. Okay, so that is what you can put in the formula for x, like for both the thing, and then you have to add. So 1 minus p. So n is here, n is 2k minus 1. So what is that? So n we can write 2k minus 1 minus 1.
Yes.
This for not happening. And then you can multiply with p. Similarly, here n is 2k.
Yes.
And then p. And you can do the summation. This was for the even and this was for the odd. Okay. And then after doing the summation, you get the value.
Okay, okay, thank you.
Yeah.
Sir, activity 2, question number 2. Can you do that?
Yeah, sure. Activity
2.
Okay, 2. Question number 2.
Yes.
Okay, see. Now, this is same type of problem. So here 10 identical independent like thing is there with in the form of geometric with probability 1/5. Like, so now we have to calculate, find the probability that x1 is greater than 10, x2 is greater than 10. So everything, all the 10 thing is greater than 10. So what we can do is all are independent. So we can calculate for 1 and then we can multiply it 10 times.
Yes, sir.
So we can calculate for 1. So if we'll calculate for 1, that is 1 minus p to the power, I guess, n, or what, n minus 1. And if that is p, and if you are doing the summation, so what would be the, if 1 minus p, here if we are getting p, so we'll get this as a common ratio. Sorry, the summation for the infinite term is a upon 1 minus r, right? So a is this one for us, 1 minus p n minus 1 p upon 1 minus n. What is the ratio for this?
1 minus p.
1 minus p is the ratio. So we'll get 1 minus p to the power n minus 1 into p upon p. So p will get cancelled. So this was the 1 minus p to the power n minus 1. And then you just have to multiply with that with n, like 10 thing, like to the power n, to the power 10. This is what has been asked in the question, right? No, then we'll get some
0.8 to the power 100.
So this is the jn thing. 1 minus p to the power jn thing.
Yeah, that yeah.
10 into 10, so 100.
Yeah, so this was probability x1 less than greater than 10. So there is direct, you can write x1 greater than 10 as 1 minus p to the power n,
J.
right?
10, sir, 10.
And then if you are having like, and the number of that was 10. So here it can be 1 minus that jn, whatever the sir has taught in the class, jn is similar to that. So you can just multiply it for 10 times. Then what's the problem in that?
Okay, sir, I understood.
So question number 3 of this same activity.
Sir, can you please scroll up and show your notes for the 2.4 activity?
2.4. Okay, where was that?
That 1 minus 2. Yeah, 1 minus p power 2k minus 1.
Okay, that one. Yeah, here.
Yeah, this one. Yeah. Okay, so we have to solve from this part, right? 1 minus p 2k into p plus 1 minus p 2k minus 1 minus 1 p, right?
Yeah, this for the one and this one, then you can do the summation.
Okay.
Yeah.
So there's one question from activity 1.7, question number 4. So I have did the solution, but I'm not getting the desired answer.
Okay, 1 second. Where is that? I lost my screen now. So okay, so 1.7. Okay, I'll go to that. First, there was one question in this same activity.
Yeah, question number 3, sir.
Okay, so the random experiment consists of rolling a fair die until 6 appears. So this is a geometric thing, right? Geometric distribution. And then x denotes the number of times the die is rolled. X is the number of times the die is rolled. Suppose 6 does not appears until the 6th row. And then find the probability that 6 will appear after the 8th row. Okay, so this is a problem of that we were discussing right in the starting, that memoryless and memoryless is just a, okay, so this is what m plus n you can consider as 8 here, m plus n as 8 here after the 8th, and you already know has not appeared till 6, so n equals to 2. See, here you have to calculate similar to right x greater than, what was that, 8 after 8 time, given that x is greater than 6. This is what you have to calculate simply. This was the 8 after 8. This is after 6th. And then it has been given okay. So the probability of happening is 1/6, and then not happening is this one. So what's the geometric progression of that? So now you can solve, I guess. This is the condition thing. So you just have to, you don't have to bother about the 6th thing. So similarly 1 up minus 6, and then you'll be getting 8 minus 6 here, because, and then the probability of occurring is 1/6. So 1 minus 1/6, and 8 minus 6 is squared, so 5/6 square. There's a, like, the maybe before this lecture that concept has been taught, that memoryless. That's why this question has been asked.
So it's like, so here we can say that, sir, can we say that here we are ignoring the first 6 trials because we didn't get the success in that? And then we are starting from fresh.
From the
right?
6th trial.
Yeah.
We are from the, that is what has been asked in the question.
So in that sense, 7th trial will be the 5/6 and 8th trial will be 5/6. So that's the concept, sir.
Yeah, after 8th now. Yeah, that would be the same thing. Okay, after 7th and 8th. If we are starting something from the 6th and then from the 8th, so the common would be from the 6th, 8th.
Greater than 8.
Yeah, the same thing. So that's why we'll get, because if we are calculating for greater than 8, so 8, and then we are subtracting for 6, so yeah, the same thing. Like after 6, we have started from the 6th again, and then we'll be having the same thing after the 6th also.
Okay, thank you, sir.
So lecture 2.9, I just have a doubt in that concept that is shown in the video. Lecture 2.9.
Sir, sorry to the same question again. So actually, I'm not getting the final answer for that 2k and 2k minus 1 problem.
Okay, so I'll solve this.
Thank you.
So what was that question? One was x upon 2, and then one was x plus 1 upon 2, right?
Yes.
So if we are equating with k, one x would be 2k, and then other would be 2k minus 1, right? So what we have to do for the probability greater than 2k, it should be 1 minus p 2k minus 1, right, into p. And similarly for this one, 1 minus p 2k minus 1 minus 1 minus 1 into p, right? And we'll do the addition. So here is what. So 1 minus, what common we can take it from the both the side. P we can take the common. And this is the lesser one. So we can take 1 minus p to the power, 1 minus p 2k minus 2 we can take the common, right? So what would be there? So here we'll be having 1 minus p will be left, right?
Plus 1.
And then plus this total 1. So we'll be having p 1 minus p 2k minus 2 and then 2 minus p, right? So yeah, this would be the value, final value.
Yeah.
Have you got that?
Yeah, thank you.
Okay.
So in activity 1.7, question number 4.
Okay, 1.7. So that I have to open.
So can we discuss activity 2 video, the concept that I have taught?
Okay, I'll just open that one, week 1 now.
Yes, sir.
It will take time to open. Okay, till that time we can discuss second.
Sir, video 2.9, lecture 2.9.
Yeah.
At 7.40. Yes, sir. Sir, significance of this formula. Now, can we simply enter 1, 2 and get the probability of any value with when we have to find out max between x and y? If yes, then what is the use of PDF that is given?
See, sir has just calculated, has shown how you can calculate. Just like you can do the summation, like that will be in the form of some like triangle, and then you'll just add.
So if we are given simple the range is 1 to 6 for x and y, can we use this formula and calculate the probability of say max between x and y, which is equal to z? Would that be the interpretation of this?
Yeah, you can calculate for sure. But the thing is, if the number is very small, you can just however I have solved for that 4 or 5, that table, simple table you can draw and then you can solve. That would be a better way. Like you can visualize also. Here, if the value of n is very big, so that thing you can't do, like the table thing you can't do. So that's why you can solve with this. It's a one type of problem. There can be 1,000 number of problems. It's just for the sake this uniform and this pretty like simple, so you can just memorize this, nothing more than that.
Okay.
Yeah, but if the value is very small, you can just draw the table and just go to the calculate the range, and then with the help of range you can you can calculate the maximum of that, like xy also. Like you will be able to
But
see.
just in case where the n is very large and we have to calculate some probability, we simply use this formula as is.
Yeah, if the ID is uniform, then only you can use this.
Only with uniform, yes. Okay, fine. Thank you, sir. Thank you.
So yeah, so activity or practice assignment question or graded anything from anyone you can ask. Like graded, we can just discuss the some concept, not like whole solution.
Sir, week 2 tutorial to question number 6. I have doubt.
Okay, week 2.
Yes, so even I had the same doubt in that.
Okay. So yeah, tutorial.
Second.
Okay.
Question 6.
If let x and y be the two independent geometric distribution and a variable, assume that z equal to x minus y. Find the value of fz, like the PDF you have to calculate when the z x minus y is 1. Okay, so the range for x can be any natural number excluding 0, like all the natural number. Similarly for y also it can be anything, because we are dealing in geometric distribution. Then tz can be from minus infinity to infinity, that you got, like anything if that x is infinity and then like 1 is 0 and then 1 is infinity, so you can get anything from minus infinity to infinity. So you have to calculate x minus z as 0. So what they have done, okay. So where you are facing the problem in calculating, which equation you are facing the problem? Can you tell me? Are you able to hear me?
Yes, sir. So basically the formula I'm not getting, how to apply the formula in this type of problem.
Okay. So there were there was some video in which sir has taught if you're having some x plus y sort of thing. if you're having some x plus y equals to z, and then if you have to calculate the what the PDF for some z equal to z, then how you can do the summation from minus infinity to infinity, and then like if you have to calculate the joint PDF, then what you can do, you can just take the probability x equal capital X equal to x, comma what capital Y equal to y. Okay, so y you can replace, and then y can be what, like y you can replace in the form of z minus x, right? And you can do the addition, like it's a discrete, so you can do the addition for all. So this is the this is what has been used in that question also. So this is similar to like if you are doing something like that. Okay, this formula you would be knowing already. Or similar way, if you are replacing x with z, z also can be replaced, like x also can be replaced in the form of x minus y, and then in the form of y, and then you can do that. And if that is independent, you can just multiply both the marginal thing and you'll get the answer. Or there is another method also, that like convolution and all. Like convolution and all, it's not like just the formula has been taught. So in the similar way here also, we were having what x minus y, like there it was x plus y, here it is x minus y, so x can be 1 plus 5. Okay, so in the similar way, if we are defining something like probability x equal to I plus, if just taking y as a I, so we can do that summation from I is equal to 1 to infinity, just write it minus infinity to infinity, and then we'll see for which and all values that y has been defined. Okay, and if that is independent, we can just like do in the form of product, and then that is a bit lengthy question, but yeah, but that's why it's given in the form of tutorial, so that you can practice and then you can learn sort of thing.
So can you solve practice assignment to question number 6?
So what you can do in practice assignment 2?
Yes, sir.
So I have a doubt in question number 2 of the practice assignment.
Okay, I'll open that. Which question?
So question number 2.
Sir, I have one doubt in an activity question.
Yeah, one thing. So the second question is, two fair dice are thrown simultaneously. Let x be the outcome for the first die and y be the sum of the outcome on the both the dice. Okay. So x is generally what? X is.
So I'm getting 7 by 12 in the final answer, but
Okay. So x you can take, what are the values x can take?
so 1 to 6.
So 1, 2, 6, right?
So what I have done is I have taken 2 instances of the roll of dice. So x1 and x2 both will be taking values from 1 to 6. And then I have taken separately y to be taking values from 2 to 12.
How can see y will be taking what?
No, yeah, y is correct. But what I'm saying that I have separately considered both the rolls of the die. So I have taken two random variables, x1 and x2, both taking values from 1 to 6. And also y, that is the sum.
See, y is the sum of whatever we are getting. Like, for example, we have got like 6 in the first and then second in 6 also. So the range would be from 2 to 12. Okay.
So to get the difference, y
Simple,
minus...
Wait. You just have to calculate probability such that y minus x is greater than equal to 6, right? So do you think the difference can be more than 6 here?
Yes, so for that the...
No, for example, for just think, can you think of any, like the difference would be 7?
7? Yes, sir.
When?
The difference would be... Oh, no.
It can't be, right? So only the 6 can be the...
Okay.
So, so only one thing, and the z, the difference, what? Y minus x has a range of, I guess, 1 to 6, and that is also uniform. So 1 upon 6.
So y minus x has range of 1 to
6. It can be 1 to 6 only. If we are...
So 6 is exclusive now.
Let's say y is the sum. So y has to be from 2 to 12 and x can be from 1 to 6. Okay, so the problem is that x and y both are dependent. That is why I had taken x1 and x2 to be two separate roles of the die.
Okay, it's fine. Okay. Whatever. But here the question simply has asked z is one random variable we are defining as y minus x. What would be the range of? So the first and most important key, you should find what are the values that z will be taking. Z would be taking, I guess, 1, 2, 3, 4, 5, 6 only.
6.
Okay.
And y minus z, when is greater than equal to 6? Only for 6, right?
Yes.
So that's why. And for each, it's a uniform. So for all the, like, for occurring of all the random variable that is in the z, the probability would be equal. So 1 upon 6 should be the value for...
So I was not able to at an instant get this range for z. I was thinking that the y will be varying from 2 to 12 and the first row will be from 1 to 6, but then it clicked me that both are dependent variables. So it will depend on the value of x, that this sum has to be according to the value of x only.
Okay. So then what you have done?
I have done is, I can share. What I did is I took the pairs of sum and the first roll of the die, that is x.
Okay.
So what I have done is for this sum to be greater than equals to 6, the value of y should be greater than equals to 7 and the value of x should be greater than equals to 1, but both are dependent.
But 7 is not possible, right?
So y is the
y
sum
can
of...
be 7, but the difference can't be 7.
Yeah,
If
nice.
you're rolling two dice, if you're rolling, like,
only.
for example, I'm getting in one, if you're getting 5, if you're getting 1, and then the second also, if you're getting something, the difference can't be 7, right?
Yes, sir. So the sum can be from 2 to 12 and
so just a bit of clarification.
Yeah.
What is y and what is x here now?
Y is the sum of the two dice.
Yeah, that's up to 12 it is there.
Yes, sir.
And x is 1 to 6, no?
Yeah, but both are dependent.
Yeah.
No, hold on a minute. Whether it's dependent or independent, we'll just hold it for some time.
Okay.
So 12 minus 1 is 11, no?
Yeah, it's 11, but you can't get that. That is the thing, no? This dependent.
Yeah, when the number on the first die is 1, we cannot have the sum to be 12.
Yeah.
That is obvious.
11 on the second die, right?
Yeah, only the first is 6 and the second is 6. Then only you'll getting the z as that sum as 12, right? But
so
you can't get.
That is a situation where x is equal to 6, is it? So y is equal to 12, max 12. So
the confusion
y
is
minus
arising.
6, is it? Y minus x, that is that x should be used to take the difference.
So the confusion is because of the second variable being the sum. If we consider both the roles of the die as separate variables, x1 and x2.
Yeah, that's what I was thinking. Where is the statement that is telling it is dependent? Which statement is leading us to take that position that x is dependent?
So they will be dependent on each other, no?
Where is that?
X is
Which
the first rule
statement?
of the die.
See, why if you are ran, for example, one dice is this one, D1. Everything can't be in the form like written. If you are getting something from D1 and then we are getting something from the D2.
Okay.
Okay. So if we are getting something like the and the what is that? Z is the different. Y is simply D1 plus D2.
Yeah, D1 plus D2. So now the value of D1 will dictate the value of Y.
And D1 is simply X.
Yeah.
Okay.
Then D2 we have to think of a separate roll of die taking values from 1 to 6. So what I have done is I have taken pairs of the sum and the first roll of the die. So the sum for the values for Y to be for the difference to be greater than or equals to 6, the values for Y will range from 7 to 12. And the values of X, that is the first roll of die, should be greater than or equals to 1.
Yeah, it got to be.
So let me share you what I've written.
I don't
Can I
think
share? Okay.
I don't think you can share the screen. Wait a minute.
Sir, I have a doubt in activity question.
One sec. Yeah. But the thing is, okay, I can see that what you have written. I think you're on mute or what? You can't.
Sorry. Yes, I was on mute. Sorry.
Okay.
X1 is the first roll of the die and X2 is the second roll of the die and Y is the sum. So X1 and X2 and the ranges are given here. So for this condition to satisfy, that is the Y minus X1. Okay, I have taken X to be as X1. Is that okay?
Yeah, you have taken X1. Okay, fine. So X1 and X is same for you.
Yeah. Just So for this condition to be satisfied, Y has to be greater than or equals to 7 and the first roll has to be greater than or equals to 1. So the pairs that I have made for this condition are such like this. This is the Y, okay, and this is X1.
This is the one thing you have got. But the next one, 8,2. If you are getting X1 equal to 2,
then X2 is equals to 6.
Okay, fine.
Then if here it is 8,1, then X1, if X1 is 1, then X2 has to be
7. That is not possible, right?
Yes. I don't know why did I miss. Okay. So this is possible, right?
Yeah, this is possible. Again, the next one is not possible.
Okay, I did not.
9,1 is also not possible. So there are so many things that you have to remove.
Silly. Okay, I'll get the right answer now.
Yeah.
Okay.
Sir, I have a doubt in activity question.
Thank you.
Yeah.
I have doubt in activity 1.7, question number 4.
Sir, I have doubt in activity 2.4 question, last question.
I
Okay.
think 2.4 last question we have discussed. I have asked it, right? That one.
I have got network issue, that's why I'm not there. So can you please?
Which one?
2.4 last question, sir. Geometric distribution one. Fourth question.
Okay, fourth one. See, fourth one is what? Like there's a geometric distribution, the x in the form geometric distribution, then you have some function wherever like x is defined as even, then you'll be okay. I'll share my screen.
Yes, sir, please.
So you'll be having two things. One is x by 2 will be equating with k, and x plus 1 by 2 is equal to k, because you have been given fx is equal to k, right?
Yes, sir.
So here you'll be having 2k, and here you'll be having 2k minus 1, right?
Yes, sir.
For geometric, you have to calculate the probability such that x greater than 2k, and here x greater than 2k minus 1, and you have to do the summation, right?
Yes,
so for the geometric distribution, 1 minus p to the power, what is that? Generally you write n minus 1, so 2k minus 1.
2k minus 1.
Okay, and then 1 minus p,
Yes,
2k
sir.
minus 1, this minus 1 is from the formula, and then you multiply with, and you'll add, you'll get, yeah.
Sir, I have done it manually there. Like the professor said in the lecture, you have to find the possible values of fx, and I have done the
Your
same.
voice is not like
I
your
got
voice.
for 1 and 2. Sir, now it's clear?
No, your voice is
So is
not
it clear now?
Yeah, tell me.
Sir, I have done like professor said in the lecture. I found the possible values of fx, and as it is geometric distribution, I have got the possible values of x is 1, 2, 3, and till infinity. Now I'm calculating possible values for few terms like x 1, 2, 3, and 4. And now after that I will generalize it. I have calculated fx is equals to 1 for 1 and 2. Then I got fx the PMF for x is equals to 1 minus p to power 1 1 p and 1 minus
Yeah,
p to
wherever you
power.
will get 1, that is for the odd, and this is for the even, right?
Yes, sir. 1. Yes, sir.
So this is for the even, and this is for the odd, and you will do the summation of the probability. That's
Yes,
it.
sir.
Okay. So we have done the same thing.
But sir, I'm getting different answer. I'm getting the third one option correct as my answer. And I don't know why it is happening.
Yeah, this is correct, no? No, this is correct, I guess. A is correct.
Yes, sir. And I'm
Maybe
getting second option.
Okay, second you're getting. So, okay, maybe you would have done some like mistake in algebra, I guess.
So I have checked it thrice. I don't know what I'm getting wrong. And
okay, then one thing you can share that picture to me. Maybe I can sort it out. Yeah, okay, that would be fine. Maybe I'll check it. Huh?
Sir, I'm with my mobile phone. Can I share the photos of that?
You can share to me like on the mail ID. That thing you can do.
Sir, on which mail ID? Sir, on support one.
You can mail like Vishal@online degree.
Sir, can you please repeat the email ID? Vishal.
Vishal@online degree.
Online degree. Okay, sir. I will do that.
.iitm.ac.in. That you know already, right?
Yes, sir.
Yeah.
Can you please solve activity practice assignment to question 9 and 10?
Sir, I was waiting for activity 1.7.
I'll just open that 1.7, right?
Yes, sir. So if you can just write the solution, what I did, I can tell it to you. That also would be fine.
This is 1.7, huh? 1.7
yes,
is where. I don't know where is that.
So you can write it down somewhere. I can tell you the solution. From there,
Okay.
it will be clear.
But I don't know the question.
So everything is in the
Yeah.
solution only.
1.7. Okay. Which one?
So question number 4.
Okay.
So
This is
here,
a question of marginalization, right?
yes, sir. So here
Okay.
I have we have to find fx1 given x2 equals to 0, comma x3 equals to 1 of 0. So for this we have to first put the joint probability of fx1, x2, x3 with 0, 0, 1 upon marginal probability of fx2, x3, 0, comma 1. And
Yeah.
for this, what I did, we are given the numerator value as 1/5, the joint PMF of fx1, x2, x3, 0, 0, 1. But we don't know the marginal PMF value of x2, x3 with value 0, 1. So for this, I have written it fx2, x3, 0, 1 equal. If you can just write down anywhere, so it will be easier for me to explain.
Yeah, 1 second, I'll write it.
So I've sent it to your email address.
Yeah, tell me.
Yeah, so fx2, x3 with the value 0, 1 equals to joint PMF of
Sir, I
fx.
think the screen share has stopped. Sorry to interrupt.
Yes, sir.
Yeah, 1 second. Yeah.
Yes, sir. Now I can see it. So fx2, x3 with value 0, 1.
x2, x3.
Yeah, with value 0, 1 equals to joint PMF of x1, x2, x3 with value 0, 0, 1.
Okay.
And plus joint PMF of x1, x2, x3 with value 1, 0, 1.
Joint PDF of?
So same thing, same variable x1, x2, x3 with
Hmm.
values 1, 0, 1. So one more, this formula, sorry, this equation, if you can write just below. So it is fx2 given x3 equals to 1 with value 0. Fx2 given x3 equals to 1 with value 0.
Okay.
Equals to joint PMF of x1, x2, x3 with value 0, 0, 1 plus joint PMF of x1, x2, x3 with values 1, 0, 1.
Yeah.
So for this thing, we are given the we are given this for second equation, this RHS thing fx2 LHS thing fx2 given x3 equals to 1, 0 as 2, 3 for second equation.
For second equation?
Yeah. This so this LHS part is given as 2, 3.
2,3. Yeah.
Sorry, 2 by 3, 2 by 3.
Okay.
Yeah.
Oh. Okay, 2 by 3.
Yeah. And so this joint PMF of x1, x2, x3, 0, 0, 1 is given as 1/5. And so we can find here from here this joint PMF of 1, 0, 1.
Okay.
And we can also put it here.
Here.
Yes, sir. In the first
Okay.
equation. And so for this, we can find, we are also given this value 0, 0, 1.
And this has been given.
Yes, sir. So we can put it into this fx1 given x2 equals to 0, x2 equals to 0, x3 equals to 1 of 0 as the joint PMF of 0, 0, 1 upon marginal PMF of x2, x3 with value 0, 1. So I am substituting all the values, but I'm not getting the desired answer. If any of this equation is wrong, if you can tell me. So
I got. Okay, I'll try to solve this. So what you can do, you can send me your solution, and then I can point it
can I
out.
explain
Maybe.
you here? So this marginal PMF of x2, x3 with value 0, 1 is something that we are fixing 0 and 1. for x2 and x3.
Yeah.
Then
We are
we are
fixing
left
zero.
with x1 as 0 and x1 as 1 because it is x1 is uniform with
Yeah, it's fine.
having
It's
value
fine.
0 and 1. So I think this equation is fine for the first equation.
Yeah.
But sir, we don't know the joint PMF of 1, 0, 1. For this, we are using this thing, which is given here. The second equation is given, second equation LHS side is given here with value 2, 3. If x2 given x3 equals to 1, of 0 is given in the question 2 by 3. So we are
I think this
using
equation is given, or this equation you have wrote. I think this is wrong.
There's no equation given.
no, sir, not this equation. The LHS part is given.
Okay, but I don't think so. This equation is correct.
So like
because
in the question it's given fx3 of 0 is 2 by 5. But in the question what is asked is if x1 given x2 is equal to 0 and x3 equals 1 of 0.
So I think that this equation you have to think again. This is not correct because if you say this is correct, then what's the difference between this conditional and then this marginal of x2?
Yes.
This both you are telling same equation, right?
So
the joint distribution of x1
from
2.
this we can say that x3 is 1, which is given. x3 is 1, so it will be 1 for both the things, and x2 we have to find for 0, so 0 is also fixed. So now now also we are left with x1 with two values 0 and 1. So
But
I
that is
didn't
not
understand this thing.
Okay, so this is not correct, I guess. This equation is not correct. This one.
So sir, how will get this joint PMF of 1, 0, 1?
One second. This was the question, right?
Yes, sir.
Okay. So you have x1, x2, x3, 0, 0, 1 as 1/5, and then you have this marginal is this one. Okay, so you just have to think something. Sorry. So we have to evaluate x1 equals 0, comma x3 equals to 1, 0, right? So what you can do?
Actually, we have to find f of x2, x3 of 0, 1 first. With this.
Yeah.
So we know an equation which is always true.
F x2 given x3 is equal to 1 of 0 is given.
This is what 0,
1,
1, right?
Yeah.
And this is what 0, 0,
0, 1.
This has been given or what? Is this given?
No, we have to find that.
The numerator thing is given. We have to find this marginal PMF of x2, x3.
Yeah, this we have to find. Okay.
This we can find from the conditional probability and.
Yeah, this can be find from the conditional this point, right?
Yeah.
So this will be right 1/5 upon this can be calculated from here. So for this, we have been given sorry.
So in the denominator, we have to multiply by fx3 given.
Yeah. 2 upon this is what this is
Yeah.
You can
4.3.
directly do this. If you have some condition, then you can multiply with marginal and then we can get. So what is that? 2 upon
3.
3 into
So into 1 minus 2 by 5. That is 3 by 5. 3 by 5.
3 by 5.
3 by 5 by 3 actually.
No, 3 by 5.
This is 2
Yeah.
1 minus 3 by 5.
Yes.
Yeah,
So
but we
you
have to. Yeah.
1 upon
Yeah.
5 into 2 upon 5. So 1 by 2 you'll be getting. I guess in this way you can get.
So can you explain this denominator thing? I didn't understand this thing.
So what we have done here, so we were having fx2, this is what? This is marginal. This is the conditional we have been given, right?
Yes, sir.
Okay. So for fx2, how generally we write? fx2 0, 1, we have. So we have this conditional as fx2 conditioned on 3 equal to 1, 0 multiplied with fx
3
of 1, right?
Okay, sir. Now I got this.
So that would be 1 minus. Yeah.
Yes, sir. Yes, sir. Thank you, sir.
Yeah.
Hello, sir.
Yeah.
I have a doubt on activity 2.11.
Yeah. So 2.11, right?
Yes, sir.
Which question?
Sir, question number, sir, second last question, I think.
Question number?
Sir, 6. Question number 6. Sir, in that question, I'm getting answer option 2, but here it is written option 1 is correct. So, can you please explain? Actually, I have calculated probability for x equals to 1 and x equals to 0, and then added it and subtracted from 1
so, yeah.
to get that. But
So what we have to calculate here, Z2 is what? Z2 is minimum or maximum?
Z2 is minimum.
Okay. So Z2 is minimum of x1 till x10. We are having 10 trial, right?
Yes, sir.
So what we can do, generally we have to calculate the CDF, right?
Yes, sir.
So for CDF, it's generally x less than equal to n. But
yes, sir.
It's better to calculate x greater than n, and then we can do the subtraction of 1 from that, right?
Yes,
and
sir.
then
I
we'll
have
be
this.
getting. Okay. So what we
yes,
can
sir.
do, we can just calculate, this is a function, minimum of x1 till xn, x10, right?
Yes, sir.
So this all minimum, like I can take this as a some z2, right? Minimum greater than, we are calculating for greater than, and then we'll do in the end, we'll subtract that from 1, right? We'll get the same CDF. Okay.
Okay, sir.
This is the one way. So what we'll do, if everything, if this z2 is greater than, what was that, 2, right?
Yes, sir.
That means what? If the minimum of something is greater than 2, so all the terms should be greater than 2.
Yes, sir.
Right?
Yes.
Correct?
Yes, sir. Yes, sir.
So if x1 is greater than 2, then x2 should be greater than 2, x3 should be greater than everything, right?
Okay. Yes, sir.
So now I can, how I can write. So, so for, similarly, we have to calculate for one thing, 2, and then we can multiply it 10 times.
Oh, 10. Yes, sir.
Okay. So for x greater than 2, we can write this as the probability as what? 1 minus probability of x less than equal to 2, right?
Yes, sir.
Fine.
Yes, sir.
Okay. So x less than equal to 2 means what? X equal to 0, x1 equal to 1, and x1 equal to 2.
2. Yes, sir.
Right? And we have been given this binomial of like how many, what's the value of n here? N is 6, right?
Yes, sir.
So what we can do for n equal to 6, for x1 equal to 0, 1, 2, we can do this one, n 1 minus 6c0 1 upon 2 to the power 6
Yes, sir.
plus 6c1 1 by 2 to the power 6 plus 6c2 1 by 2 to the power 6, right?
Yes, sir.
Okay. Now what we can do is, where is the summation? 1 minus, this is what? 6c0 is 1, right?
Yes, sir. 1 by 2.
1 plus 6c1 is 5 and 6c2 is 6 into 5 upon 2, 15.
61 is 6.
So 61 is 6.
Okay, 61 is 6. And we'll be having 2 to the power 6 in each of the term, right?
Yes, sir. 1 by 2. 6.
So we'll be having how much? 1 minus 22 upon 2 to the power 6, right?
Yes, sir.
Whole to the power 10.
Yes, sir.
And this is what? Probability of this minimum of x1 greater than 2, right?
Yes, sir.
This is all we were calculating for minimum x greater than 2, right? Have you got the point? This is all we were calculating for x greater than 2. And now what we have to calculate? We have to calculate minimum of this less than equal to 2. That means what? We have to do this one. So we have to subtract from 1, right?
Subtract from 1. Yes, sir.
So how much we are getting? This is 1 minus, what is 2 or 6 is 64 minus 22 upon 2 to the power 6 to the power 10 is 44 and 2 upon 2 to the power 6 ka power 10, right?
Yes, sir.
And then we'll do that subtraction, 1 minus this one.
Yes, sir. Okay, sir.
So this would be the answer. Like you have to just arrange in the form of answer. What is the value of answer here?
21 by 2 to the power. Yes, sir. It will.
It's correct. Oh, yeah, it's fine then. We were getting 42 upon 2 to the power 6.
Yes, sir.
Yeah.
Thank you, sir.
So there is one question in activity 1.4, question number 4, where Poisson distribution has been discussed. So I didn't understand the Poisson distribution part, so I didn't get the question.
1.4.
Yes, sir. Question number 4.
See, Poisson and all, I can explain you in like one session I'll be taking, but I'll just in the brief I'll tell you what is Poisson. Like, Poisson is like, it's a type of discrete distribution only. Okay, discrete probability distribution. Okay, like for example, I'll tell you in some fixed interval of time, some event has occurred. Okay.
Yes, sir.
So like in some generally Poisson distributed is in the form of lambda. Lambda is generally the mean value, so constant you can say, and the PDF of this is generally in the form of e to the power lambda. Sorry, it's wrong.
E to the power minus lambda, right?
E to the power minus lambda.
E to the power minus lambda, and then lambda to the power k.
K by k.
K factorial. Yeah. So it's generally like, what you can say, like if some thing has been like I can just refer the how to explain that.
So you can take that question for the explanation.
Okay. So which question is that? Like one?
So activity 1.4, question number 4.
In week 1, Poisson is not, I guess, discussed. Poisson would have been discussed in week 0, I guess.
Yes, sir, but there is one question of Poisson distribution.
Okay. Yeah, where is that?
So 1.4, question number 4.
Just asking distribution of X. Okay, so here it is the number of, so that what I have told, there should be some interval should be given and then some occurrence of thing in that fixed interval should be happening. So the number of customer arriving at a shopping center in 1 hour interval, it's been given already. Ki the number n is in Poisson distribution with the lambda 20, right? Assume that the probability of customer making a purchase is, and the probability has been given of 0.4. And the choice of purchase of the customer is independent, like for each and every customer, like it's a totally independent thing. Let X be the number of customers who are making a purchase. Identify the range. So I think so this type of question has been discussed in the class, like lecture, right?
Yes, yes.
So the first one, if you are like, generally what happens in this type of question? Wait. This is the same question, I guess. So there won't be any problem in finding the range, right?
Yes, sir.
Yeah, that is clear.
Okay. If that is asking for that the distribution, then can you mute later? My voice is echoing. Yeah. So there I see. If you'll go through the video, that was 1.4, right?
Yes, sir.
That would be where.
So
in that video, sir would have
provided in that area.
What?
So there was a calculation provided in one of the area, one of the lecture to identify the final lambda value actually. So the Poisson distribution value.
Yeah. So lambda generally.
So here basically 20 into 0.4 is what we have to do, which is Poisson distribution of 8 actually.
Yeah, that is fine. Just 1 second. That was in the 1.4, right?
Yes, sir.
Common distribution.
Okay. So this question, I guess, right?
Yes, sir.
Yeah, correct.
Yeah. So if you're having some like n has been given in the form of Poisson distribution, okay, and if that value like n, like in this question I'm telling you for this question, then we'll discuss for that one. If in this if the n is the Poisson distribution, and you have to know regarding the like if what you are doing, tossing a fair coin n times and denotes the number of head obtained by x. So the x, the value of x here, it is the number of heads. There it was the, I think the related to customer, how many customers and all that's coming. You have to find the distribution for that x. Okay. So
Yes,
here
sir.
the number of, yeah. So x would be totally dependent on
I
n.
think the probability there actually in the sum 0.4 probability is given actually.
Yeah, yeah. 0.4 is given. Yeah, yeah, correct. You are correct. I'm just explaining the things. So yeah. So here the number of heads will depend on n, right?
Yes, sir.
Right?
Yes,
Okay.
sir.
So that's why we have to if we have to calculate the conditional thing, that will come in the form of, will be binomial. Why it would be binomial? Because see, x was the distribution, like x we have to calculate the number of heads here. Okay, and that head there, the customer, that question was whether it can come or not, those sort of things was there. The probability 0.4 and for not occurring 0.6. Here it is 0.5, 0.5. This is the question. Can you relate the things?
It's basically till what time that particular occurrence or experiment is happening, right? So till head coming, what exactly the probability is that? We understand correct?
But can you repeat that? Can you come again?
Are we calculating till the heads or number of heads that is that we are trying to identify in the next sequence or something like that? How many heads that are being coming? So that is what we are identifying here, right? So is that when we use binomial? So
Yeah. See,
when actually use binomial, I think that is what
see,
my understanding. I'm not sure.
binomial is similarly like if you are having Bernoulli, your understanding, if you're having something, the occurrence, there is a sort of like probability of occurrence. There is only two things can occur, either head or tail, or that is Bernoulli. And if you are repeating the Bernoulli, you'll get the binomial. Okay. So here, n, like n you are getting from some distribution, some Poisson or anything. Like here it has been given Poisson. Okay. And for that n, whatever the n you are getting, you're just tossing the coin for n times. And then whatever the head you are getting, you have to do the distribution for that number of counts you are getting for the head here in this question. Similarly, in that question, what you were asked regarding the number of customer coming in that sort of interval. So here, the way here it has been given, head, it can come head or tail. In a similar way, there, whether the patient, I'm telling, that customer can come or not. So the coming of the customer, the probability was 0.4. For not coming, it was can be 1 minus 0.4, so 0.6. So in the similar way, you can approach the question. Whatever has been for the conditional, you can approach like a binomial thing, and then you already know if you have to get the joint distribution of x and n, then you can just do conditional you already have got, then you can multiply with the marginal thing.
Marginal.
Okay, marginal is this Poisson. So there also the Poisson was given one thing, marginal, right? One thing you will get from the binomial.
Yes.
And then you can multiply it. You'll get the end result. And the end result was what? In the end result, we're getting as that the distribution was Poisson with lambda by 2. Right? So we got like some sort of thing. Or
I understand some things here, like we are getting the marginal using this fn of n kind of, and we are
why
getting the
we are getting?
conditional.
Because n is like x is totally dependent on n.
Yeah.
Because if we don't know the n, we are not going to talk how many times we'll toss, we don't know. Then how can we get the head or tail? Like if we are not knowing how many times we are tossing the coin, how can we get the distribution? Right?
So what is interval here?
Interval is not sort of like it's just given in some sort of interval, lambda times it has been occurring.
Okay, okay.
So
sir, is it Poisson lambda by 2 is a general formula in such cases where n is the
every
Poisson?
time, every time if you have been given some Poisson, this is important also. Like you can get this sort of question in the exam, like quiz also. So that's why I'm telling you.
Yeah.
So if you are been given n as a Poisson, like the number of times you are getting from the Poisson distribution, this is a one standard example I'm telling you. Not like if you are having n as a Poisson, and if you are getting the conditional as a binomial, like this here it is binomial, in that case also it's a binomial. Binomial, how will you identify that is a binomial? If you are repeating one sort of things again and again, sort of thing again and again, and in that one sort of thing, whatever you are repeating.
For a limited number of times. Am I right, sir?
Yeah. So limited number of times you are repeating, and for that repeating whatever the event you are repeating, you should be having only two probability, like sort of occurring and non-occurring thing.
Yeah.
So that is generally a
Bernoulli's.
Bernoulli, you'll get the binomial with n. So here it has been clearly you can identify it is a binomial with n, with the and the probability also has been probability here you can know okay, it's a fair coin, so probability will be 0.5, 0.5. So you can conclude that the conditional you can conclude from the binomial, and you have the marginal as Poisson. So you can, if you have to get the distribution of x, you can just multiply both the things and you will get x, right?
Whether sir, this formula for marginal fxk is a general formula we can use anywhere.
If you have the n as a Poisson, and then if you are getting binomial as the conditional, then you can use it. Like
directly we can use it, no?
You
Lambda
can use
by
it
2.
directly, but everything you have to see whether that n is in Poisson distribution or not. Okay.
Yeah. If condition is the same, Poisson and the binomial both are there, and we need the marginal fx of k, then we can use it, right?
Yeah, then you can use it. Otherwise, you can't.
Okay. Can you give an example of that, sir? That's why.
Yeah, there was an example in the like, what was the question number 1.4 only? The question was there.
Okay.
So here it was. So range you can identify easily. So here also in 1 hour of interval, n you have been given with Poisson 20 as lambda. Okay. So the probability of customer making a purchase is 0.4. So not purchasing is 0.6. So two things are happening. Like for one event, either the patient, like the customer will purchase that or not purchase. So the probability of purchasing is 0.4. For not purchasing is 0.6. Okay. So now you have to calculate the distribution of x. So here the same question, n is Poisson, and that conditional thing is also in the form of binomial. Okay.
So sir, then what is lambda here? Lambda is 20, na, sir?
Lambda is 20 here. Probability p is 0.4.
And
yeah. So in the similar way, you can just
probability of purchasing by a customer. This is probability of the customer purchasing, right, na, sir? 0.4.
Yeah, it's probability of purchasing
and not purchasing is 0.6.
Yeah. So the
So how we will write it using binomial?
Which
what can
you
you
repeat?
repeat?
Please.
So how we will find it using the binomial? What will the value of n?
So n here is not n means n you are getting from this Poisson.
Yeah.
Okay. Right. See, just relate with the same like question has been discussed in the class. Maybe you'll get more. So for this here also, the n will be, you can just think of.
So for binomial, we use like NCR, then p to the power r, then 1 minus p to the power n minus r.
Yeah.
So what would be n or r here?
See, out of, like, for example, if we have got n as capital N, so out of n is the total number of like customer is coming, and out of that customer, if like like is purchasing something, so the probability of that is NCR 0.4 to the power how many purchasing the like P customer is purchasing. So I'll write it.
What is P here, sir? Exactly.
See, if n was the Poisson, so n customer is coming, right?
Okay.
And out of that n customer, see, R is purchasing something with a probability of 0.4, right? And 0.6 with not purchasing. So not purchasing is n minus R, and then purchasing is like, I wrote it 0.6 and 0.4. Right? This is a form of binomial.
Yes, sir.
Binomial with n and then 0.4. Right?
Yes, sir.
And this is a conditional thing. X conditioned over n, right? Have you got the point?
0.4 to the power R, na sir?
Yeah. 0.4 to the power R is purchasing, and 0.6 to the power n minus R is not purchasing. Okay, so you'll get the binomial in the
power
form
n
of
minus R, correct?
Yeah. Okay, similarly you can do this one, joint distribution. You can just multiply those things, or you can just sort of think, yeah, lambda by 2 would be the new lambda.
No, sir, in that case, the probability was half for both.
Yeah. Yeah, for the earlier case, it was 0.5 and 0.5. But this
and for head and for tail both.
Your voice
here
is
it
not
is
like
different.
Your voice is not
It is
clear.
0.4 and 0. Am I audible, sir?
Yeah, now
is it audible, sir?
Yeah, you're audible.
Yeah, actually, what I mean to say, sir, in that case, the probability was half for both, for head and for tail, both.
Yeah.
Coming or not coming, both. But here, probability is different. So
yeah, 0.4 and 0.6.
By 2 case is, I think, yeah, here it is not same. So lambda by 2 is not the case.
No.
How to do in such cases where probability is not the same?
No, here also the lambda by 2 concept will be applicable, because what you have to think is n is Poisson distribution. Okay, and then whatever the conditional you are getting, see, it's not about lambda by 2 or lambda. For that case, why you have got lambda by 2? When you have multiplied that conditional, okay, when you have multiplied that conditional to the marginal, in the end, you were getting lambda by 2 that came in the form of Poisson, and you were getting lambda by 2 as the new lambda. Okay.
But sir, this lambda by 2 came because the probability was half to the power n.
No,
and
that is
2
not
to the
related
power
to probability. No. That's not related to probability thing.
Okay.
For all the probability, you will get lambda by 2. That's not related to probability.
So can you please solve here, sir, so that we can identify that same thing. It comes
Okay,
like that.
I'll just explain the same thing again.
Yeah.
Please solve for the question number 4 so that we can understand.
Okay. See.
Yeah, because that is lambda divided by the probability is what that is coming up, right?
See. Here the question is, see, here the probability, where the probability we are not using anywhere. See,
1 by 2.
Using, sir, yeah, 1 by 2 is to the power n is the probability.
Tossing a coin, right?
Okay, wait. See. So what we have did, we have just
tossing a coin is not similar to the purchasing by the customer. What I mean to say.
Yeah, you just
so
mute for some
what
time.
to do?
Just mute for some time. Okay.
Okay, sir. Okay, fine. Sir.
See, what we will do here. So till here everybody would have known ki, yeah, this same lambda and all the number value, the value won't affect anything. Again, here the binomial is 1/2. So here it has been taken 1/2 will take 0.4, right? No, will not take 0.4 every time. It will take 0.4
No,
and
0.4 and 0.6.
0.6.
Correct.
Both will take, right?
Yeah.
So just take, okay, if we'll take, I need to write that. Okay. So what was that? Fn was Poisson, right? Poisson we can write as 1 minus lambda to the power n factorial, right?
Correct.
And for the condition was in the form of binomial with n.
Yeah.
0.4.
N comma 1/2. Sorry. Yeah. 4.
Okay. And this is our conditional thing. Condition on n, right?
Right. Yeah.
Now, and for us, this distribution would be what? This distribution would be n ck.
Yeah. 1 minus 0.4
K 0.6 n
minus k.
Right? This is the PDF of this condition, x condition n.
Yes.
And if we have to get the joint distribution, for n k, what we can do, we can just multiply both the. So e to the power minus lambda to the power n by n factorial
Into this. Yeah.
and ck 0.4 n 0.6 n minus k, right?
First is 0.44 to the k, right?
Oh, sorry, k. Fine. Okay, fine. And then we have to do the summation. So n is the number that can be anything. N is the number of customers that can be anything, right? And then k is the number of the customer which are purchasing. So this will vary from 0 to n, right? Because n is the number of the, so the number of customer purchasing the thing can be maximum n1 out of n.
Yeah. Equal to 20.
So now this is the joint PDF. Now, but we have to get the marginal PDF for x.
And also do lambda as well, right? Lambda equal to 20. We know in this sum.
Yeah. So I'll put in lambda. Okay. So what and all thing we have to calculate for that question. So we have to get the distribution for this one, right?
So what is
Yeah,
fxk?
Poisson distribution. Yeah.
What fx?
What is fxk?
Yeah, fxk is the distribution for the number of customer. What was that purchasing the thing?
Okay.
That was there in the that was asked me the question, right?
Yeah, correct, sir. FXK. We need fxk.
Who's missing? So for this one, nobody would be having doubt why is this in the form of binomial n comma 0.4, right?
Yeah, no doubt on that.
So the joint distribution of x and n is simply this one, right?
Yeah, binomial.
So a lambda here would be 20, and then 0.4 to the power whatever. Like if you are asking for, if they are asking for 10 to, you can put k as 2 and then n as 10, right? So you'll get the value for this. Okay, and now you have to calculate the distribution of x that we are calculating, the distribution of x. Till now, anybody is having any doubt in that?
No, sir.
Yeah. So now what
Is
we'll
that
do?
continuity? Is that continuity? Do we need to use 10 comma 2 from the previous, or we can do it without that as well?
So say here 10 n is 10 and k is that you can put in the this equation you'll get, right? Or you are asking something else?
No, yeah, I'm just asking whether we want to use 10 comma 2 in the sum that we are currently working on, the Poisson distribution, or we can do without that. I don't think we will be able to do without that, right?
See, for this question, for this one, they're just asking the joint distribution of x and n, right?
Correct.
So joint distribution of x and n is this one. If we'll multiply the conditional
One, yeah.
with conditional with marginal, right?
Correct. Yeah, that's correct.
Okay, so you just have to put
For
the
the
value.
next question.
Okay, for the next question, you have to do the summation, because x, this is the, you have to do the summation for all the n, right?
Correct. Yeah, that's what I'm just asking, whether we want to do it for all, or is the continuity of the previous sum that we have to use 10 comma 2. That is what I was just
That you don't have to use.
right?
No, you don't have to use this.
Okay.
So what you will do, you have the joint distribution, joint PDF. So you can do the summation from where? Like you have to do the summation for all the x, right?
Correct, yeah.
And if you are doing it for the x, then you have to add some for the n, for 0 to infinity.
0 to infinity.
No, if you are do the summation whatever you don't want. Okay, so n you don't want, so you will do the summation for all the n, because you are calculating the marginal distribution of x. If you will do the marginal distribution of n, then you will do the summation for the k. Okay.
In place of n, we should use k, na?
Yeah, there should be k because
0, yeah.
Because
k to infinity.
That is less than k, that will not make any difference, or that will be 0 till k. It would be 0. From n equal to 0 to k, it would be 0. The probability would be 0, right? So from
why
k,
it would be 0?
because if you are having less than k as a customer, like if you are having 5 customer, if you have 5 customer, 5 number of the customer has came and 6 has purchased, that can't be possible, right?
Yeah.
Cannot be possible, yeah.
That's why you have to take from n equal to k to infinity. You have to do the summation for that, and then you have to write this one, and then you have to do the algebra. Lot of algebra there. E to the power minus lambda or n by n factorial, right? And n factorial upon k factorial into n minus k factorial, right? Then 0.4 k and then 0.6 n minus k, right?
Right. This will be.
Then what else you can do? What else you can do here? It is about minus lambda. You can write it like this. And you can, out of that n, you can take out k. And out of n here also you can take out k factorial.
Factorial n will be cancelled.
Yeah, that will get, just I'm taking out of n, I'm taking n here, and then
lambda to the power n minus k.
Yeah, this will get cancelled, right? So n k factorial will be left. So what and all we are left with? We are left with the summation.
How we are changing from n to k here, lambda to the power n to, okay, because less
Both
than
are there. NCR was there, NCK, okay. And then here, what if I'm taking out lambda, then lambda n minus k is left.
N minus k.
And then n minus a factorial
N
is
minus
there.
k factorial. And here is the
I have written here
complex.
lambda to the power k.
Where?
So in the numerator part.
Lambda, okay, lambda here, this one.
Yeah.
From n I have just taken out k times lambda, and then I have written here lambda n minus k. Now if I'll do the addition, it will get cancelled, right? Okay. And then, but in the
Sir, can we do 0.6? We can write 1 minus 0.4. Then we go for the, because the 0.4 will be common in that. 2k will be there. 1 to the power k. Let us do like that. So that
1 minus
0.6 goes out. And only 0.4 is there.
What? 1 minus?
1 minus 0.
So we should do 1 minus 0.6.
We can do 0.6 as 1 minus 0.4. Like the general equation 1 p into 1 minus p to the power n minus.
Yeah, that we can do 1 minus 0.4.
Then, yeah, let us try for that.
So, but it would be better to do 1 minus 0.6.
Yeah.
Because there's n minus k over there.
Because 0.4 is given, so let us do for that.
Yeah, I think it should work either way.
It can work, I think. 0.4 to the power k and 0.4 to the power n. Two part will be there, no, sir? Then 0.4 to the power k minus 0.4 to the power n. And both will come lambda to lambda e to the power.
Okay.
Lambda.
Okay. So what happened in that one? If we were having 1/2, we can directly write in the form of e to the power minus lambda. Right?
Yeah, yeah. But what happened in there? That's why I question asked, because the 2 is there, but when it happens, a complex is there. Then how to do this?
Okay, so it will get stuck for sure.
Yeah, I also got stuck.
What all is the options here?
If we use the previous 10,2, then we'll be able to get that Poisson distribution value, right? For that particular.
Yeah, that question. Okay, it's fine. This one, I'm asking for this one. This is the distribution.
But they have used 0.4 and 0.6 both.
Okay, what you can do? Okay, yeah, I'm getting, yeah. So I guess one thing you can do. Okay. So I think so lambda p would be the whatever the distribution in the end you will get, right? Lambda p would be the new lambda, not lambda by 2 always. Okay. Are you getting some inference from the answer?
Yeah. Lambda p can be the
lambda p would be the new new distribution, like Poisson distribution.
Let us go to the general equation, sir, and putting p, we derive this without getting without using 1/2. then we will be
Wait,
sure.
I'll come to that. Wait for a minute. How we'll get to NP? Okay, that's the point. So one thing is for sure, you will get NP. Sorry, lambda p.
Sir, lambda is always NP, sir. Lambda is always NP because lambda is the mean.
Yeah.
And the mean is always n into p.
No, not. I'm just telling you will get lambda p as the new lambda for the normal distribution, whatever we'll get after this calculation. Okay, wait, I'll try it again. So
what is lambda p here, sir? What is lambda p here?
Actually, that is the answer, right? Lambda into p, which is 20 into 0.4.
I think lambda into p is not there, sir. I think lambda by p can be equal
one
to
minute.
n.
I'll do it again.
Okay.
So what we have to get? We have to get the, what was that? We have to get the distribution of x, right? For that distribution, what we can do? We can just multiply both the thing. So we were having, so just take it as p here. So we can multiply this and this, right? E to the power minus lambda. What is it? K factorial. N C K P to the power k 1 minus p to the power n minus k, right? This was the thing we got it in the end. Yeah, here it is. This is n, right? So what we can do? This was the condition thing, and this is the binomial, right?
So we only aware with the values of p and lambda. So how we'll calculate the whole stuff?
Yeah. See, lambda only we need and p only we need. Other than that, everything is fine. N we will be getting from the Poisson. Lambda will be getting for the Poisson distribution. Okay. P only we need. P has been given, right?
It is given here Poisson 20. So lambda is 20 there.
Yeah, lambda is 20 here in this question.
Okay.
And P is also 0.4.
But sir, we don't aware with values of n and k.
Which n? Okay. See, n is fine. N you will get.
I think we are trying to prove lambda p, right? Because we
we are trying to prove. Yeah. So we are trying to prove that whatever the distribution will get in the end, that will be having the Poisson distribution with lambda p as.
Correct.
Lambda p as the new lambda, right?
Distribution. Yeah, new lambda. Yeah.
So this is generally the summation of n equal to k to infinity, right? And here it p to the power k and 1 minus p, we can write it as q to the power n minus k, right? Upon k factorial into n minus k factorial, and n get cancelled, right? Are you getting e to the power of, and then lambda to the power n, right?
Yes, sir.
And then we can just take out this one e to the power.
Sir, what is q here? Q is 1 minus p.
Yeah. Q is 1 minus p.
Okay, fine.
And then just take this p and lambda here. Lambda and p, now we can take this as k, right? Upon k factorial. Multiply with, we'll do the summation.
Did not get it, sir. Lambda p.
One second, I'll tell you. Lambda
okay, sir.
q, here n minus k upon n minus k factorial. Now tell me what else you have not understood. E to the power lambda has came from here. Lambda p lambda I have taken, k lambda I have taken, and n lambda is there. N lambda is here, and p q. So lambda p to the power k, lambda q. So q has been k, q came from here, n minus k, and lambda k I have already taken here. So what is left? N minus k is left. So lambda q to the power n minus k is left. This is the summation. Left n is equal to k to the power infinity, right?
So
Everything
please
sorted?
explain once more, please.
See, this was the equation conditional into that joint, right? Conditional into this joint. Are you getting my
Yes,
point?
sir. Yes,
This
sir,
was the
yes.
conditional, and this is the marginal. Sorry, joint and this. This is the marginal.
Marginal.
Okay. So we got the joint. From that joint, we have to calculate the marginal for x. So what we'll do? We'll do the summation from n equal to k to infinity, right? So we have pq e to the power minus lambda, lambda this one. Okay. So what we have did, we have taken out e to the power minus lambda here, and p and lambda to the power n. We were having lambda to the power n. So what I did, I took out lambda to the power k from there. Okay. So k lambda p to the power k is left. And how much lambda is left here? Lambda n minus k is left here. So I'll just put lambda q as n minus k here, right?
Oh, okay, sir.
Everything sorted out? And I wrote k factorial here and n minus k factorial here.
So what you have written here, lambda p to the power k, and what's next here?
K, just this is the just summation k to infinity.
Okay, it's infinity.
This k to infinity, the summation for this. And this is what? This is e to the power lambda p, lambda q. The summation. That is what has been taught in the class, like lecture also, right?
Okay, sir.
So this is this we have came with lambda p. What is left here? Upon k factorial.
So there's e raised to the power minus lambda only, no p.
Where?
So there's only lambda, no p over there.
Yeah. Yeah, e to the power minus lambda p to the power k is left, and this is what? E to the power lambda q, right?
Yes, sir.
So what is there if we'll add this lambda or minus exponentially? So we are left with what? E to the power minus.
So minus lambda plus lambda q.
And then we are having.
So minus lambda you can take common into 1 minus q.
So we'll be having minus lambda. And then lambda p to the power k upon k factorial, right?
Yes.
E power minus lambda.
So if we have to.
E power minus lambda, 1 minus q, it will come, right?
1 minus p.
1 minus q, which is p.
Minus lambda e to the power lambda minus lambda plus to the power minus lambda plus lambda this one, and lambda p upon k factorial, right?
Minus lambda plus lambda will cancel, so e power minus lambda p will be there.
Lambda p will be there, and lambda p to the power k. Finally we
by
got
k factorial. Yeah, we
this
got
that.
it.
Yes. Okay, so this is the distribution you are getting, right? With lambda p.
So it is into 0.4 in this case, which is equal to 8.
Yeah. So you'll get the lambda, new lambda dash as a 20 into 0.4. That is 8, right?
Yes, sir.
So
Finally, we got the
how this
solution.
lambda p came, sir? Lambda p to the power k in the state.
Where? Lambda?
Lambda p to the power k. Not
Lambda
here.
Here.
In the,
Here you are asking.
For
This
step
one.
back.
This one.
E to the power minus lambda. One back or one back.
Where? E to the power
One
minus
step
lambda.
back.
Here.
Yeah. Lambda p to the power k. How did it came?
Yeah, it came from here.
That is from the previous.
Please, sir.
Yeah.
Please, sir. Once confusion is there.
P to the power k is there, and lambda to the power n is there, right?
Yes.
So what I did, I took out lambda to the power k from there. So, so what I did, lambda to the power n is what? Lambda to the power n minus k multiplied with lambda to the power k. That is same.
Correct. That is okay, sir. Fine.
This I took it here, and this lambda I took it here. Have you got? Lambda to the power k, I just put it here, and lambda to the power n minus, just I bifurcated that, and then I just put lambda to the power n minus k here, and lambda to the power k here, right?
Okay.
Just for the simplification, so that we can come to some conclusion. So in the end, what we got, whatever the x distribution we were getting the same Poisson distribution, but the lambda was lambda into our p. So this you can use it everywhere.
And how this series came, sir? E to the power lambda q.
This is simple.
Format. This format is
this.
How? 1 plus x plus
this
x
is the
square
sum
by
of
factorial
exponential
2.
Yeah, this is sum of exponential. This summation.
1 plus x by factorial 1 factorial 2 factorial.
Yeah.
Is it coming here, sir?
Yeah, it will come. Otherwise, it will not be able.
How it will come, sir? That's what. Here.
You can just see the expansion of like exponential. You can see from Google or something.
Okay.
Yeah.
Now, what value we should take first? First value of the k will be 0 or 1.
You can n we are putting, so n will be from k to infinity. Okay, have you got n?
Because
if you put that k
for getting the series.
Yeah.
What should be the value of k first? The first term should be 1, no, sir?
Where? See, if I'll take for the summation, if I'll take k as 1.
Okay.
It should be greater than the n, whatever we are taking, it should be greater than. See, k is what? The number of, like the customer which are purchasing something.
Yeah.
So the k can be from 0 to infinity, like, but that should be less than n.
Yeah, that should be, that's what I'm telling you, sir. What the first value should we should take for k?
0 from 0 you should take.
When we will take 0, then 0 minus k will be there. Negative factorial, how? No, n will be there.
N.
Then the what? Then the first term should be 1, no, sir. It is not 1. That's why I'm telling you. 1 plus x by factorial 1 plus x square by factorial 2 plus x cube plus factorial. It should come in the series. Then only it will come like that. Huh?
See, what you are taking first term you are taking. We are doing the summation. N is the variable, right?
Okay.
So what first term I'll be taking k. First term I'll be taking n is the variable. Don't.
Okay.
So I'll taking n as a k. So I'll put here k. 0 factorial is 1.
Okay.
And k minus k is 0. So 1 upon 1 factorial is 1.
Got it. When I start with k plus 1, k plus 2 like that.
Yeah.
Okay, got it. Then it will correct. Okay, sir. Thank you. Got it.
Okay. Thank you.
So for this course, this much Poisson distribution, understanding of Poisson distribution is sufficient, or we need to look the concepts from week 0 also?
Very difficult, sir. In the week 1, it is going like.
No, you just you don't have to go through those things.
Okay, so this much understanding is sufficient for the course.
Yeah, this much is more than enough.
Yes.
And
I think to understand the distribution,
is
only
it more out of this?
What?
One chapter in week 0 is there actually, common distribution, which covers all.
Yeah. That video you can see. I think so. That is in the 0 point. The video would be 16th or 15th, 15, 16, 17. You can see.
Yes, sir.
10
I
to
have seen, sir. I have seen, sir.
Yeah. So
Yeah,
that video,
that video
whoever
would
was
be
having
helpful.
doubt in Poisson,
One question I will like to ask, sir. Somewhere I have seen in the video, n is small and n is large. The binomial and Poisson difference is that if it is more than 20, then it is Poisson. If it is less than 20, then it is binomial. Is it correct, sir?
yeah, that's correct.
We can opt it. If it is more than 20, then it is Poisson. If it is less than 20, it is binomial.
So those things will be mentioned in the question. So you don't worry about that.
Okay.
So,
fine, sir.
yeah,
And secondly,
so,
sir, the announcement has come that tomorrow there will be a session for this maximum, minimum, and IID. And you suggested that another session will be for the week zero of the lessons. Then would it not be better to go for the 0 week first and then go for that? Because first session will
so
be
you have
there.
got the announcement
and
for what? For tomorrow's session?
Just tomorrow session. I just got the announcement.
Officers covering all these actually.
Okay.
Before that, I think would it not be better to go for the first
Your voice is not audible.
week and then go for that? Yeah. What I'm telling, sir, would it not be better to go for the first 0 week and then go for the IID and maximum minima week 2?
So who will be taking the tomorrow's session? Is it mentioned?
I don't know, but announcement is there, sir. I just got the email.
No, actually.
Okay. So what I can do, I can just tell them to cover those things also. What else? I'll be.
But
Yeah,
it is
that's
not.
what I'm telling.
It is not scheduled in the calendar. It is only just.
So it is office hours. Office
Okay,
hours.
that is always our
Office
It's an office
hours.
hours.
It is in the office hours.
But where is the link for that?
Office has been received in the instruction, the first itself. So office hours are part of your in every calendars, individual calendars.
Individual calendars, office hours on Sunday.
Yeah, Saturday 8 o'clock in the evening.
8 o'clock. Oh, that's the one, huh? Okay.
Yeah, 8 o'clock in the evening on Saturdays. Yeah.
Okay,
That has
for
both
that
actually, max and stats.
But
You
they
select whatever that is.
Statistics come to right. Okay.
For that I can't do anything, but I can schedule mine for like Sunday. That is what I can do.
Okay, sir. Just I told what I got, sir, if it is possible, because I think correlation is required. If it is there, then it will be better. If
Yeah,
not,
so
then
that
we will
tomorrow's session
do it
can't be rescheduled
our
now.
own.
I can just schedule a session on Sunday or Monday that the announcement will go for the week 0 thing. Okay, week 0 or some, yeah, week 0. That will be mostly from the statistic 1. Like, yeah, so I can cover all the doubts from the week 0 that I can do on the Sunday or Monday. I'll just stop tomorrow and then I can schedule one session for 1 or 2 hours. That would be fine, I guess, right?
Okay, sir.
Okay, sir.
Okay, thank you. Thanks a lot. So now
Thank you very much, giving so much time, sir.
No, it's fine.
This course is some cumbersome, so we have to work hard for that.
Yeah, so what? Yeah, you can just like see, you can put it on the Discord, whatever your doubts is. Like many of the persons generally reply. I've seen. Even I'm like we are not replying. So many people are there who can reply in like a very quick time. Or if you're not getting, like if you're having some conceptual that you can mail to me, like I've given you the mail ID. Maybe I can send you some, like I can write and then I can send you there. So my mail ID is visal@onlinedegree.itm.
Sir, different. Just a minute. Which mail, sir?
This mail
Please
you can
share in
mail
the
if you are not getting answer on the discourse. Okay.
Okay, sir. Please share in the chat.
Okay. That you can just not like just write whatever the email ID you will be having now. You'll be having some number. Okay. Just write it Vishal and then at the rate like online degree .iit.
Sir, after at it's online degree, we have student. After at we have student.
Okay, you have student. Okay, so okay, I'll check it. I'll check mine. What is that? Yeah, this one.
Fine, perfect. Thank you.
Okay, I guess earlier I given you the phone number also.
Yes,
so
right,
we
right.
can-
Yes.
Yeah. So, but that WhatsApp number is not working now. So you can like mail me like on the email ID itself. Maybe it will, yeah. Or
Sir, what's your mail, sir? Please share it.
this is my mail ID. Vishal@onlinedegree.iitm.ac.in.
Just. Thank you, sir.
Yeah.
Thank you all.
Okay then. Good night, everyone. Thank you for staying here.
Good night, sir.
Thank
Good
you,
night.
sir.
Thank you very
Thank
much.
you.
Thank you, sir.
Yeah, thank
Good
you.
night, everybody. Thank you, sir. 150 to 50.